Okay, so we're finishing up with number 4. So like I said, this was a calculator question. And the things that you need to remember is that your mode should be in radians. Your window should go with the question, which said from 0 to 6. So when I graphed it, I just copied it here. And I said that when you see the first derivative graph, you should always be looking at the number line. That's something that you want to create. So I know I have a critical value somewhere near the value of 1, right? So that's approximately 1 here. And then I have another critical value at just something over 3. So 3 and a little bit. And so when I look at this, this is below the x-axis, so it's negative, positive, negative. And they were asking for a maximum. So you know a maximum occurs when your first derivative equals 0 and there's a sign change from plus to minus. So I've now decided that this point here, well, that's my relative max. So what you notice on my calculator, if you can see, I have a red line highlighting that x-axis. So what I did was on the y equals, I went to the second line and made it y equals 0. I did that because now when I go to graph, I'm just going to go ahead and look for that point of intersection instead of going left bound, right bound, and telling the calculator to find the 0, I'm going to just say intersect. So when I do that, my cursor's right over there. If it's not, you're just using your right or left to get to that point. Press enter 3 times. And if you press enter 3 times, that answer comes on the bottom, and that's telling me that this relative max is happening at 3.24. So your answer here would be E for number 4. Okay, next. If I'm looking at 5, they say, they give me this equation, they asking me, does this have a look? This is a very, very basic. I have one local max, one local min. That's all. They're talking about all choices about mins and max. So that's requiring me to find the first derivative. So this one's pretty straightforward. The first derivative, this just becomes 16x minus 8x cubed. You're going to GCF and 8x. You're going to be left with 2 minus x squared. You're going to set this equal 8x equals 0, so x equals 0. 2 minus x squared equals 0. I'm going to add that x squared over, square root both sides. I'm going to get 2 answers of plus or minus the square root of 2. So on my number line for number 5, not to get confused with that one, okay, I have a critical value at 0. I have a critical value at square root of 2, negative square root of 2. And if you wanted to, the square root of 2 is roughly 1.4. So this is negative 1.4, so on. And this is square root of 2. This is 1.4. So those are my critical values. So now it's up to you to find the sign change and tell me if I have a min or a max. So again, I like to visualize the first derivative factored right underneath that number line. And now I start testing. I need a number. This is roughly negative 1.4. So negative 2 or negative 3 would work fine. So if I had negative 3 here, that would become negative. So I'm testing negative 3. That'd be negative 24, but it's just negative. And then negative 3 squared is a positive 9, but 2 minus 9 is a negative. So that's going to give me a positive, so that's a plus here. Then if I try f prime of, we'll say negative 1, well, that's going to be a negative. Negative 1 squared is 1, 2, that's going to be a positive, so that's going to be a negative here. And then when I try a positive 1, f prime of 1 tested, that's going to become positive here. This is positive, so that's a positive. And the last one, if I try f prime of 2, well, that's going to be positive there. And then 2 squared is 4, 2 minus 4, that's a negative. Well, that's going to be a negative. So now I have a max, I have a min here, and then I have a max. So the answer here is I have 2 relative max and 1 relative min. So 1 min, 2 max 1 is choice D. So 5 would be D. Okay, moving on to 6. All right, to number 6, if you're looking at this, it says they gave you this box, they gave you information on top. I want you to always read everything. I just wrote down the important information. They're telling me f prime is always decreasing. Okay, so there's a couple of things that can come from that, but I know that that means f prime is decreasing. Which of the following must be true? So you start looking at this. Relative max at x equals 3 for f of x. Well, if I'm looking at choice A, does f of x have a relative max at x equals 3? Well, let's see. Do I have f prime of 3 equal to 0? I do. Okay, so right now I do know that 3 is a critical value. Now, they're telling me for my f prime at 1, it's 8, somewhere high. F prime of 2, it's 4. Then f prime of 3, it's 0. Sorry about that. And then f prime of 3 is 0, f prime of 4 is negative 4. Now they told me something super duper important. They told me f prime is always decreasing, so it's always going down. Why'd they have to tell you that? Well, because if they didn't, we couldn't assume that this went in a straight line. We could have said, hey, it could have jumped back up and come back down. But that's not the case. It went from positive to negative. So I do have a maximum here. This is true. This must be true. So anytime I'm looking at this, and especially when my first choice seems to be the answer, I always look at my other choices just to make sure that I didn't read something or forget to consider something else. So B says I have a relative min at 3. Well, we know that's not true because it's going from positive to negative. And if not, you see it. F prime at 3 is 0, and there's a sign change from positive to negative. Okay, so that's definitely, B's not the answer. It's concave up for all of x. Well, let's think about that. If f prime is decreasing of any sort, and I say this is f prime of x, and I'm doing tangent lines along that, the second derivative, well, that means that the tangent lines for a decreasing function will always be negative, which would mean that it's actually concave down throughout. So this is not true. And then they said graph of f of x is symmetric with the line x equals 3. They gave me no information for symmetry there. And then f of x changes concavity at 3. I don't have enough, that will not be true just based on that fact that it's going down. So it is choice A. Okay, moving on to 7. So 7's interesting because there's a lot to question here. They're asking you, they would like an equation of a tangent line. So as soon as I say, oh, read the equation of a tangent line, immediately I go, oh yeah, I need to deal with y minus y1 equals m times x minus x1. And I need to figure out my slope, which is the derivative, dy dx, or f prime, and I need to know the point. Okay, so when I look at this, it says they give me f of x, so I know that I have a function to take the derivative of, and they say the point, they want it at its point of inflection. So that's interesting. I need to find the point of inflection first. So how do you find the point of inflection? That's coming off the second derivative. So this is I'm going to use the first derivative as well for the slope. So let's first we can't jump to the second derivative, so we find the first derivative. I get 6x squared minus 6x as your first derivative. And then I'm just going to go ahead to the second derivative because I'm looking for the point first, and I get 12x minus 6. And I set that equal to 0. And I get 12x is equal to 6 divided by 12, x is equal to 1/2. So I know that my critical value, is x equals 1/2, and I'm going to test into that. When I test a 0 into this, I get a negative, And when I test a positive one, I get a positive. So this is going to be a POI, a point of inflection. So to find that point, remember, I identified the critical value of the second derivative being set equals to 0 with the sign change. But now I have to plug in f of 1/2 into 2 1/2 cubed minus 3 times 1/2 squared. So this just becomes 2 times 1/8 minus 3 times 1/4, which this just becomes 2 times 1/8 is just 1/4 minus 3/4, which then gives me negative 2/4, which is just negative 1/2. So the point is 1/2, negative 1/2. So now this is the point that I'm going to use. I know this is y minus negative 1/2, so that becomes positive, is equal to m times x minus 1/2. So now I'm just left to find my slope. Well, I know that my first derivative is right here, and I need to find the slope when x is 1/2, because that's the x value of the point. So it's going to be 1/2 squared minus 6 times 1/2. So that's just going to give me 1/2 squared is 1/4. 6 times 1/4 is just going to be 3/2 minus, this is going, I'm just going to leave this as 6/2, and I'm going to get a negative 3/2 as my slope. So my final answer is y plus 1/2 is equal to negative 3/2 x minus 1/2. All right, so that was a lot of work understanding to find the point first, point of inflection coming off the second derivative, finding the y value using the original, and then finding the slope at that x value of the point. Okay, next, when you look at number 8, if I look at this, it says the derivative of function f is given by, and they give you this function. On what interval of the graph is it concave down? Concave down, you know that that's the second derivative being negative. So you're just going to head and saying, oh, they gave me the first derivative, so I don't have to take 2 derivatives, I just have to take 1 more. Well, how are you going to take the derivative of this? It's going to be product rule with chain rule involved. So here we go. Your second derivative is equal to the derivative of the first times the second plus the derivative of the second, which is just 1, times the first. And we're just going to clean this up. And I'm going to have an x plus 1 come out from the first. And then what's left is a 2 and an x minus 2 for the first one, and then just an x plus 1 here. So again, you're going to continue. You're going to get x plus 1 out. This is going to be, I'm going to do this up top here, 2x minus 4 plus x plus 1. So that's going to clean up to be 3x minus 3. And then I just go ahead and set it equal to 0. So I get x plus 1 equals 0, x equals negative 1. And here I get 3x minus 3 equals 0, x equals, if you add the 3 and divide by 3, you get x equals 1. So you have 2 critical values of negative 1 and 1, and you're just going to test into that second derivative, which again, I always like it right underneath there, x plus 1, 3x minus 3, and then you're just going to test your values. So if I test a negative 2, I'm going to get negative 1. Hold on, I'm pausing.